Hello, I welcome you to Winkle's class. Today's video is meant to help us understand how to solve problems relating to material balance in biochemical engineering, especially when you are dealing with biological processes like fermentation. Material balance simply has to do with calculating the quantity of materials that enters and leaves whatever system that you are using, whether a bioreactor, a fermenter, or any other plant that helps you to convert your raw materials into a product of interest. This question will help us explore several ways that we can solve problems like this when we come across them in real life situations in our laboratories or industries. The question talks about the flow of 2000 kilograms per hour of aqueous solution of ethanol from a fermenter is to be separated by continuous distillation into distillate and waste solution. Calculate the amount of distillate in kilogram per hour and the amount of waste solution also in kilogram per hour. Now, to be able to solve this question perfectly, one must have a slight idea about the law of conservation of mass, or more simply, material balance. Let me put the question in one corner so that we can have more space to do our writings. With that, I think we are set to go. From the concept of total material balance, we usually equate whatever we input into the system to be exactly equal to whatever comes out of the system plus whatever gets accumulated into the system. So we usually use the relation input is equal to output plus accumulation. Pardon me, anytime I write ACC, it means accumulation. So input represent the quantity of reactants or substrates or our raw materials that we pump into the fermenter or our system. And then the output represents the desired product or whatever waste that we produce out of our input. And then the ACC represents the accumulated reactants in the system. So this is the general relation that we usually use for mass balance, where we say that whatever we input into the system should be exactly equal to whatever we get out of the system. And should anything get accumulated in the system, we add it to it as well. Alright, now following this, let's look at what the question tried to ask. The question says that a flow of 2000 kilograms per hour of aqueous solution of ethanol from a fermenter is to be separated by continuous distillation. So the term there, continuous distillation, you realize that this particular system is a continuous system. So we don't expect anything to get accumulated into the system. Rather, we expect whatever we input into it to be exactly out of the system. So in this case, from our general equation, the input is equal to output plus accumulation. This time, because it's a continuous system, we don't expect anything to get accumulated into the system. And as a result, our accumulation, which is ACC, will be equated to 0 in this particular situation. And if accumulation is equal to 0, then it implies that our equation becomes input is equal to output. As simple as this. Now that we have gotten our perfect equation, let's say equation 1. Now let's look at what the question is asking again. It says that we should calculate the amount of distillate and the amount of waste that was produced. So our main focus here is to calculate the quantity of waste and the quantity of distillate that was produced after the process. So now inputting the parameters into our equation, we realize that the initial raw material that was pumped into the system was aqueous solution of ethanol. So from the question, the input material is equal to ethanol, but then it is in the aqueous form, which means that it is not a pure ethanol, but rather it is combined with water. So input was ethanol, and then the output, pardon me to write OT, output is equal to our distillate, which is D, plus our waste solution, which is W. From this, if we want to write the complete equation, we will realize that we'll end up writing ethanol, pardon me to use E, should be, which is our input, should be equal to D, which is our distillate, plus W, which is our waste solution. Okay, now that we have gotten our parameters down very well, now let's write our complete equation 1. The equation 1 is supposed to be in this form. The quantity of aqueous solution of ethanol that was pumped into the system was 2000 kilograms per hour. It was 2000 kilograms per hour. And then we see that because that is the input value, it should be equal to our distillate, which is the quantity of the distillate produced, plus the quantity of the waste solution that was produced at the end of the process. And we'll call this particular equation our equation 1. Now let's read the question further. When you read the question, you realize that into brackets, it was indicated specifically the quantity of ethanol that was present in each of the components. So it says that initially, the aqueous solution of ethanol was made up of 10% ethanol. And then the distillate that was produced was made up of 90% ethanol, as well as the waste solution being made up of 0.5% ethanol. This means that we can also express the material balance for ethanol as well, or the mass balance for ethanol. Don't forget, anytime you are solving a problem and you have two variables that you have to work for or look for, it shows clearly that you need to be thinking about simultaneous equation. And as a result of that, we are going to develop another equation that we are going to use in relation to this to get the answers. So now let's derive the solution for the mass balance for ethanol. So let's say mass balance for ethanol. It also follows the same procedure, which is the input is equal to output. Okay, now what quantity of ethanol was pumped into the bioreactor? It was what, 10%. But then 10% of what quantity? It was 10% of the total input value that was placed into the reactor. Therefore, our equation looks this way. We need 10% of ethanol out of our total input value, which is 2000, being equated to the output in the distillate. From the question, it says that the distillate was made up of 90% ethanol. So it means that 90% of the distillate is ethanol plus 0.5% of the waste solution also being ethanol. This particular solution indicates our equation 2. So you realize now that we have two working equations that we can actually use to derive the value or the quantity of the distillate and the waste product. Now, having these two equations in mind, all you have to do is you make sure you solve the two equations simultaneously, and with that you end up getting the values for D and W. Now let's go and look at how possibly we can solve this particular question. Now you realize that we have our total input, which is 2000, being equal to D plus W. Using the substitution method, I would make D the subject, and I'll end up getting this. Now I'm going to input or substitute this value of D into the equation 2, which is the equation that we wrote for ethanol mass balance. And that particular equation is 10% of 2000 being equal to 90% of D. Now you realize that D here is 2000 minus W plus 0.5% 0.5% W. Okay, so with this in mind, let's see. When you calculate 10% of 2000, you would get 200 as your answer. And then when you calculate 90% of D, you will get 0.9 multiplying our bracket 2000 minus W plus, when you also work out 0.5% of W, you would end up getting 0.005 W. Now with this equation, if you work it out perfectly, you would end up getting the value for W, which is supposed to be 1787.71 kilograms per hour. This value represents the quantity of waste solution that was obtained after the whole process. Now with the value of W in mind, which is 1787.71. Now all you have to do is to substitute this value into our D equation, the equation in which we made D the subject, which was D being equal to 2000 minus W. Now when you do this very well, you realize that your final answer for D would be 212.29 kilograms per hour. So with what we just did, you realize that we used the mass balance equation for ethanol together with the mass balance equation for the whole system in order to arrive at the quantities or the specific masses of each of the products that was produced at the end of the process. This is how each and every question under material balance is supposed to be handled. When you have the question, always read through and then figure out what quantity was inputted into the system, and then what was produced at the end. And if you're able to get these things and then the quantity of some of them that was produced, you would be able to solve the questions perfectly. If you find this video helpful, I would like you to like the video, share the video, if possible comment on it, and most importantly subscribe to my channel so that you can have access to subsequent videos that I'm going to release.